We're going to spend a significant amount of time in the land of functions. There are many different types, but it's important to know that a function is a rule that establishes a relationship between two quantities called the input and the output. For each input, there is exactly one output. Super important right there. Exactly one output. More than one input, though, can have the same output. So what could a function look like? Here's one. The input 0 gets mapped to 3, 1 gets mapped to 1, and 3 gets mapped to 1. This is okay. You can have more than one input go to the same output. And 4 gets mapped to 2. It's important to note at this point that one input can't go to more than one output. So for example, let's say I had 7 right here and 1 pointed to both. This would all of a sudden not be a function because 1 is pointing to 1 and 7. You can't point to 2. But it's okay if both 1 and 3 both point to the same output. There are other ways to show a function. One way to describe a function is to make an input-output table. This is just a table that lists the inputs and the outputs as shown in the diagram. So in this case, when you plug in 1 into the function, it outputs 1. When you plug in 2, it outputs 3. 3 goes to 6, and so forth. So sometimes when you have a whole lot of points, you're not going to draw that kind of blob diagram like this because it might be a little hard to have so many arrows going all over the place. And instead, you will create a table. Two super important terms that you must know are what the domain and range of a function are. The collection of all input values is the domain of a function. So in this case, these would be the domain. The set of all of these values would be the domain of the function. And the collection of all the outputs is the range. So the domain is right there in red, and the range is going to be all of these. So if I asked you what the range of that function would be, you'd say the range is 1, 3, 6, 10, 15, and 21. And if I asked you what the domain was, you would say 1, 2, 3, 4, 5, and 6. Functions can appear all over the place. Here's one place a function will appear. The diagram shows the first 6 triangular numbers, 1, 3, 6, 10, 15, 21, after which continue on following the same pattern. So what you're going to do first is make an input-output table where the input is the figure number and the output is the number of blue dots. So 1 correlates to 1 dot, 2 correlates to 3 dots, and 3 correlates to 6 dots. So first we're going to make an input-output table that keeps on increasing. And here's the input-output table that we end up with. Figure 1 correlates to 1 dot, 2 to 3, 3 to 6, 4 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here would be the input-output table for this function, which maps the figure number to the number of dots. The second question asks, does the table represent a function? What you need to check is to see if any inputs go to more than one output. Do any inputs go to more than one output? Well, 1 goes to 1, 2 goes to 3, 3 goes to 6, 4 goes to 10, 5 goes to 15, and 6 goes to 21. There's no splitting. Nothing from the input goes to 2 outputs. So yes, you can say that this is a function. Yay! Now what about the domain and range? Simply put, the domain is the collection of all of these numbers. So you would say the domain is the set of all numbers from all the integers from 1 to 6. And what about the range, which is the collection of all the output values? And right there is your range. It's the collection of all output values. You could be given a function that's kind of in written form, like this one. You're at an altitude of 250 feet in a hot air balloon. You turn on the burner and rise at an altitude of 20 feet per minute for 5 minutes. Your altitude h after you have risen for t minutes is given by the function h equals 250 plus 20t. So this is our function. And also, this is only for when t is between 0 and 5. So this is between the first 5 minutes. It could change after 5 minutes, but we're looking at the first 5. For several inputs t, use the function to calculate an output h. What we're going to do is plug in everything from 0 all the way to 5 into this function and create an output table. So here it is. We plug in 0 into the function and we end up with 250. Plug in 1, we get 270. Plug in 2, we end up with 290. And you kind of see a pattern. It's going up by how much each minute? 20 feet each minute, which is what the problem already described. But you're doing that because you're doing this algebra right here to generate these outputs. So here's your domain, and here is your range. Now you could organize it in a table. Here it is. It's a lot easier to write all the information out this way. You don't have to write T multiple times. You don't have to write H multiple times. Everything is really clean, neat, and easy. You could then be asked to graph the data in the table. You could use this graph to draw a graph of the function. So we're going to take these points right here. These points, right here. So the first point is going to be 0 to 50. Second point is 1 to 70. And you end up plotting a function that looks just like this. So what is the domain of the function? Well, the collection of all inputs you have 0, 1, 2, 3, 4, and 5. So that's the domain. And what's the output? What's the range? The range is the collection of all of these values right here, the collection of all of the output values. So you would say the 250, and then the next y value, and the next y value, the next y value, the next y value, the next y value. It's important to realize you can describe a function in 4 primary ways. In an input-output table, you can describe it in words, you can describe it in an equation, and you can describe it in a graph. We're going to do a lot more with functions. I hope this video was helpful.